Under integration of vector, here the problem is evaluate integral over C f vector dot dr, where f vector equal to x square I plus y cube j, and curve C is the arc of the parabola y equal to x square in the xy plane from 0, 0 to 1, 1. So in this problem, we have to evaluate this line integral for the f vector they are given, and C is the nothing but the arc of parabola. So in the xy plane, we know r vector is nothing but xi plus yj. Therefore, dr vector is dxi plus dyj. So in the our function is nothing but f dot dr. So we have to find f vector dot dr. So which is equal to f vector what they have given x square I plus y cube j into dot dxi plus dyj. So by using the dot product, what we will get x square dx plus y cube dy. So integral over C f dot dr is nothing but integral over C x square dx plus y cube dy. We have to evaluate this integral. See, this is the single integral, but we are having two variables. So we have to convert either y to x or x to y. According to this, by using the given curve, here the given curve is the arc of the parabola, that is y equal to x square and dy equal to 2x dx. So we are changing y to x, and they have given x limit is from 0 to 1 and y also 0 to 1. We are picking x, so x varies from 0 to 1. So here the given integral is equal to 0 to 1 x square dx. In the place of y, we substitute y equal to x square. So we will get x power 6 and dy is 2x dx. So which is equal to 0 to 1 x square dx plus 2 x power 7 dx. Now we can do the integrate. So which is equal to x cube by 3 plus 2 x power 8 by 8. So when we apply the limit, we will get 1 by 3 plus 2 by 8. So which is nothing but 7 by 12. Okay, the next problem is f vector equal to 3x square plus 6y I minus 14y plus 20x square k. Evaluate integral over C f dot dr, where C is the, here they are given C is the straight line. Straight line joining the points 0, 0, 0 to 1, 1, 1. So R vector means that is xi plus yj plus zk. So here the dr means dr vector is nothing but dxi plus dyj plus dzk. So here f dot dr we can find f dot dr is nothing but 3x square plus 6y dx minus 14yz dy plus 20x z square dz. Okay. So here we have to convert all the variable to the single variable. Okay. So for that they have given straight line, that is our curve. So for that you have to find equation of straight line. Equation of straight line joining 0, 0, 0 to 1, 1, 1. So by using the formula, what is the formula? X minus x1 by x2 minus x1 minus x1 by x2 minus x1 is equal to y minus y1 by equal to z minus z1 by z2 minus z1. So this is x1, y1, z1, x2, y2, z2. This is x2, y2, z2. So substitute the value, we will get x minus 0 by 1 minus 0, y minus 0 by 1 minus 0. We have to equate to some variable t. So we will get x equal to y equal to z equal to t. All the variables are equal to one thing, and dx equal to dy equal to dz equal to. So our integral over c f dot dr is equal to integral over c. What is our f dot dr? 3x square plus 6xy dy minus 14yz dx dy plus 20x z square dz. Now we have to evaluate the single integral. We have to change everything into the other variable, that is t. So in the place of x, y, z, we have to substitute t. So what you will get? 3t square plus 6t dt minus 14. Here also you substitute y equal to t, z equal to t. So we will get 14t square dt here plus 20t cube. X is t, z is t into dt. And the limit of t, what is the limit of t means? Here all the variables are varies from 0 to 1. So t is also varies from 0 to 1. Now we can do the integration. So the first term integration 3t cube by 3. Second term 6t square by 2. Third term minus 14t cube by 3. Fourth term t power 4 by 2. The limit is 0 to 1. Now apply the limit. We will get 1 plus 3 minus 14 by 3 plus 5, which is nothing but 13 upon. The next problem, show that f vector equal to 2xy plus z cube I minus x square j plus 3x z square k vector is a conservative vector field. Also find the scalar potential. So when we say the F vector is a conservative vector field means the curl F is 0. So we have to prove curl F equal to 0. So curl F, how to find? Here it is nothing but the determinant whose first row is ijk and the second row is dou by dou x, dou by dou y, dou by dou z, and third row is 2xy plus z cube minus x square 3x z square. So I vector into 0. Dou by dou y of this term is 0. Dou by dou y of set of this term is 0. Minus j vector into dou by dou x of this one. So what is that? We will get 3z square. Minus dou by dou z of this one is 3z square. Plus k vector into minus 2x. Okay. Dou by dou y of this one is also we will get minus 2x. So it may be plus x square. So here the correction is plus x square. So dou by dou x of this one is 2x minus dou by dou y of this one also 2x. So we are getting curl of is 0. So F vector is conservative vector field. To find scalar potential, so for that we have F vector equal to del phi. So F vector is, what is F vector? 2xy plus z cube I plus x square j plus 3x z square k vector equal to del phi. Del phi is nothing but grade phi, that is I vector into dou phi by dou x plus j vector into dou phi by dou y plus k vector into dou phi by dou z. Now you get the like components. So what you will get? Dou phi by dou x equal to I component, that is 2xy plus z cube, and dou phi by dou y equal to x square. Okay. So dou phi by dou z equal to 3x z square. See, from this we have to find phi. We have to do the integration. Then only we will get the phi. See the first one. Here we have to integrate partially with respect to x, treating other variable y and z are constant. So the first term integration is first equation. The first term is write 2y as it is. X integration x square by 2. Here z cube is constant, so z cube x. Here we are treating y and z are constant, so we write f1 of y comma z. So second one we are doing integration with respect to y, treating x and z are constant, so we will get phi equal to x square y plus function of x and z. Third one is we are doing integration with respect to z, treating the variable x is constant. So 3x write as it is. Z square integration z cube by 3 plus f3 of xy. So 2 get cancelled, 3 get cancelled. So we have to combine all these 3 phi and write the single phi. First write this two term x square y plus x z cube. See here for the second term x square y already it is there. We should not repeat the terms because we did the partial integration. So don't read this one and also don't write again write x z cube. So plus So this is the scalar potential.